Deep beyond the orbits of distant icy worlds are two objects that have almost ceased to belong to the solar system. Their signals are getting weaker. The space around is getting darker. The solar wind, which once filled the void with the energy of the star, gradually disappears behind, dissolving into the interstellar medium. There begins another region of space, cold, rarefied, and almost motionless. That's where the Voyagers continue to go. They were created in an era when giant planets were lined up in a special way. This arrangement occurs extremely rarely. The gravity of Jupiter, Saturn, Uranus, and Neptune allowed them to pass through the entire outer solar system, using the acceleration of each planet as a giant cosmic acceleration. This window did not last long, and when it opened, the two devices went towards the outer worlds.
At first, the space around them was filled with light. The inner regions of the solar system still retained the density of particles, magnetic fluxes, and pressure of the solar wind. But with every billion kilometers, everything began to change. The space was becoming more empty. Temperatures dropped to almost absolute zero. Even the sunlight turned into only a faint glow against the background of endless darkness. The first giant on their way was Jupiter, the largest planet in the system. Its atmosphere looked like a raging ocean of clouds. Planet-sized hurricanes have rotated for centuries. The red spot turned out to be not just a storm, but a colossal system of winds that has existed longer than many epochs on Earth.
Lightning in the clouds of Jupiter flashed more powerful than any thunderstorms in the inner part of the system. The radiation belts around the planet were so strong that the space near Jupiter became one of the most dangerous regions known in the vicinity of the Sun. But the satellites turned out to be even stranger. Io looked like a red-hot world of continuous eruptions. The surface was constantly torn apart by streams of sulfur and lava. Huge volcanic emissions rose hundreds of kilometers. The internal heat of this moon was created by the monstrous gravity of Jupiter. The planet literally deformed Io with its gravity, heating its interior.
Europe turned out to be the complete opposite. Its surface was covered with ice crossed by giant cracks. Under this icy shell was hidden the global ocean. The dark water under the many kilometers of ice existed in complete darkness, far from the heat of the sun. Later, it was Europe that would become one of the main objects of the search for extraterrestrial life. Ganymede turned out to be the largest satellite of the system, larger than Mercury. Callisto has preserved an ancient surface covered with the traces of billions of blows. Each of these worlds looked like a separate planet with its own history. After Jupiter, the spacecraft continued to move towards Saturn. From a distance, Saturn seems calm, but up close, it turned into a complex system of rings, storms, and icy worlds. The rings turned out to be not solid structures, but countless fragments of ice and stone. Some particles were the size of dust. Others reached the size of mountains. They moved around the planet at tremendous speed, forming the finest structures, waves, and ruptures. Titan, Saturn's largest moon, has become one of the most mysterious objects. Its atmosphere hid the surface under a dense orange haze. Later, it turns out that there are lakes of liquid methane, rivers, and rains of hydrocarbons. It was a world where the chemistry of the atmosphere resembled the ancient processes of the early Earth, but occurred at temperatures capable of freezing most known substances.
After Saturn, the paths of the spacecraft separated.
One went further, to Uranus and Neptune. Uranus turned out to be a strange giant, as if turned on its side. Its axis of rotation lay almost horizontally relative to the plane of the orbit. Because of this, seasons on the planet lasted for decades. The poles alternately plunged into continuous darkness and the same endless sunlight. The atmosphere looked calm, but under the outer layers there were powerful winds and icy depths saturated with ammonia, water, and methane. His companions looked destroyed and deformed. Miranda stood out in particular. The surface of this satellite resembled fragments of different worlds, as if it had once been destroyed and then reassembled by gravity.
Neptune became the last planet on the way. Even at this distance from the Sun, its atmosphere remained active. Wind speeds reached values exceeding the speed of sound. Huge dark vortices moved through the blue clouds. The planet's internal heat continued to fuel the atmosphere, despite the faint sunlight. Triton, Neptune's largest moon, turned out to be one of the coldest known worlds. But even there, movement processes took place. Nitrogen geysers ejected matter above the surface. Triton's orbit was reversed. It was moving around the planet in the opposite direction. This indicated that it had once been captured by Neptune's gravity from distant regions of the outer system. After flying past the planets, another stage began. Now there were no new worlds in front of the devices, only the border of the solar system.
For a long time, it was believed that this area would look like a clear line, but space turned out to be more complicated. The solar wind, a stream of charged particles from the sun, gradually slowed down as it collided with the interstellar medium. A huge area of interaction was emerging, stretching for billions of kilometers. This boundary is called the heliosphere. Inside it, the influence of the sun dominates. Beyond it, the space of the galaxy begins. Voyagers were the first objects to reach these areas. Their instruments recorded changes in magnetic fields, particle density, and cosmic radiation. The solar wind was weakening. The number of high-energy particles from interstellar space increased. The cosmos was becoming different.
When one of the spacecraft crossed the heliopause, the boundary between the solar wind and the interstellar medium, an event occurred that had never been directly observed before. For the first time, an object created inside the solar system was in the space between stars. But even there, space was not completely empty. The interstellar medium consists of extremely rarefied gas, dust, and magnetic fields. The density of matter there is negligible. Sometimes there are only a few atoms per cubic centimeter. But it is from these clouds that stars and planetary systems are born. Voyager signals now run for many hours. Their power is so small that they almost disappear against the background of space noise. Each transmission is a weak fluctuation of energy that crosses billions of kilometers of space.
Gradually, the devices lose energy. Their systems shut down one by one. Temperatures are dropping. The devices fall silent. But the movement continues. In thousands of years, they will leave the Oort cloud, a giant region of icy objects surrounding the solar system. There may be trillions of cometary bodies that have survived since the formation of planets. This area is so vast that even light passes through it for many months. Next, real interstellar space will begin. One device is moving in the direction of the constellation Giraffe. The other is in the direction of Ophiuchus.
but the distances between stars are so enormous that even in tens of thousands of years, they will not come close to any system. And yet, their flight will continue.
Millions of years of cold, radiation, and micrometeorites will gradually change their surface. The metal will become brittle. Dust particles will leave traces of impacts. But in conditions of almost absolute emptiness, destruction occurs extremely slowly. On board each device, there are gold plates. They contain information about the world from which this flight began. Sounds, images, signals, the position of the sun among pulsars. This is a kind of time capsule sent to the galaxy. But that's not the main value of Voyagers. They changed the understanding of the outer solar system. Before their missions, many of the giant's moons were thought to be dead, icy bodies. It turned out that some of them are more active than planets. Volcanic worlds, subglacial oceans, atmospheric cycles, complex magnetic fields, all of this lurked beyond the orbit of Mars.
Even the very border of the solar system turned out to be different. The heliosphere does not look like a perfect bubble. Its shape depends on the movement of the sun through the galaxy, interstellar magnetic fields, and cosmic ray fluxes. Perhaps it is elongated. Perhaps its structure is constantly changing. And beyond this border is the Milky Way, a giant spiral galaxy inside which the solar system moves. Its diameter exceeds 100,000 light-years. There are hundreds of billions of stars inside it. Interstellar clouds form new systems. At the center is a supermassive black hole, Sagittarius A star. Right now, Voyagers are only in a tiny region of this galaxy. They hadn't even come close to its edges yet. For the Milky Way, their movement is almost imperceptible. But it was these devices that became the first objects that began a real journey between the stars. Over time, the sun will continue to move around the center of the galaxy. The orbits of the stars will change. Some systems will converge, others will go further. After millions of years, the location of the constellations will become unrecognizable. But two small objects will still fly through the darkness. And the farther they go, the stronger the sense of the scale of the cosmos becomes. Even speeds sufficient to fly through the entire solar system are almost useless at interstellar distances. Light years turn the galaxy into an ocean of emptiness. Between the stars lie colossal spaces where almost nothing happens. Only rare atoms, magnetic fields, and ancient radiation from the early universe cross this darkness. But it is in this void that the history of the galaxy is hidden.
Voyagers pass through this stream of time. Their journey has long ceased to be a mission to the planets. Now it is a movement towards the future of the galaxy itself. Every year, the distance increases even more. The sun turns into a particularly bright star among the rest. The planets are left far behind. Even the heliosphere gradually becomes a tiny region with an infinite interstellar space. And ahead is only the Milky Way. Its spiral arms are filled with clouds of hydrogen, blue supergiants, supernova remnants, and black holes. Some regions of the galaxy glow brightly with the birth of new stars. Others are immersed in dense dust shadows. Radio radiation, X-ray flashes, and gamma rays continuously cross space.
And somewhere inside this structure, two devices continue to fly, gradually disappearing into the darkness. Their signals will one day be completely silenced, but even after that, they will not stop. They will move through cold regions of interstellar gas, past invisible clouds of hydrogen, through the magnetic fields of the galaxy. Perhaps in millions of years, they will cross the outskirts of other star systems. Perhaps they will pass near dead planets or brown dwarfs hidden in the dark. The space around them will change. Some stars will explode in supernovae. Others will turn into white dwarfs. The galaxy will collide with the Andromeda galaxy. Spiral arms are deformed. A slow merger of two giant star systems will begin. In billions of years, the Milky Way will change shape completely. And somewhere in this process, the Voyagers will continue their endless movement. They have long since become part of the cosmos itself.
The boundary between the solar system and the interstellar medium is not a sharp line. It looks more like a complex collision zone of streams, the solar wind and the pressure of galactic matter. In this region, everything becomes unstable. Particles ejected by the sun lose speed, contract, and bend under the influence of external interstellar pressure. The space here no longer belongs entirely to either side. Beyond this zone begins an area where the influence of the sun weakens so much that its magnetic field no longer shapes the environment. The flow of charged particles becomes the background, not the dominant force. It is here that the structure of space changes its nature. It becomes more foreign in composition, although in fact it remains the same vacuum filled with rare atoms and radiation. Further, beyond the visible boundaries of the planetary system extends a cloud that has not been directly observed, but whose existence is determined by the movement of long-period comets. It is a gigantic spherical structure, a cluster of icy bodies left over from the formation of the sun and planets. Each of these bodies is a solidified fragment of ancient material that has hardly changed in billions of years. Within this region, space becomes even more empty, but at the same time more saturated with traces of ancient gravitational history. It is through this zone that Voyagers pass, although the cloud objects themselves are too far away to be seen directly. Their movement here is no longer related to planetary dynamics. There are no orbits in the usual sense, only the inertia supported by the initial impulse received decades ago during the flybys of giant planets. Over time, the environment becomes more and more homogeneous. Magnetic fields lose their structure and cease to form complex vortices. Particles of solar origin disappear completely. The influence of the sun is no longer felt as a system, but only as a weak direction from which the flows of energy once came. And yet, even in this area, space is not static. It is filled with movement, but on a different scale. Streams of interstellar gas slowly flow through the galaxy. They are formed by explosions of ancient supernovae, ejecting matter thousands of light years away. These streams carry with them elements created in the cores of long-extinct stars. Each atom here has a history that goes back to the past, which can no longer be restored in full. When the Voyagers finally leave the influence of the heliosphere, they enter a region where the cosmos begins to belong to the galaxy as a whole. Now their movement is determined not by the sun, but by the overall rotation of the Milky Way. They become part of a galactic flow, a slow rotation of hundreds of billions of stars around the center. In this structure, everything moves, but the scale of the movement is so great that changes become noticeable only at intervals of time exceeding millions of years. Stars describe huge orbits around the center of the galaxy. Some pass through dense arms, saturated with gas and dust, where new luminaries are born. Others retreat into rarefied regions, where space becomes almost empty even by galactic standards. Between these zones, there are transition regions, where the density of matter dramatically changes. Here, cosmic rays pass almost without obstacles, and the radiation of ancient stellar flares still continues to propagate, gradually losing energy. The Voyagers move through this structure without resistance, but also without support. Their systems are gradually moving into minimal operation. The energy of radioisotope sources decreases. Instruments that once detected powerful streams of particles near planets now record only rare fluctuations in the interstellar medium. And yet, even this weak data matters. They confirm that space outside the solar system is not empty. It is filled with a subtle structure that becomes visible only with prolonged measurement. The density of particles may be negligible, but it exists. Magnetic fields may be weak, but they permeate space. The radiation may be scattered, but it never disappears completely. Over time, the spacecraft enter an even more stable region of the interstellar medium, where the density becomes almost constant. There are no abrupt transitions, no boundaries, only gradual changes stretched over vast distances. The cosmos is becoming extremely homogeneous, but this homogeneity is deceptive. It hides the dynamics of the galaxy underneath. The galaxy continues to rotate. Her sleeves slowly shift. Gas clouds collide, contract, forming new stellar foci. Elsewhere, old stars complete their cycle, ejecting matter back into space. This cycle of matter creates a continuous evolution of the structure of the galaxy. Somewhere in the depths of one of the arms, a giant molecular cloud is compressed. The pressure of gravity increases. The temperature inside is rising. Protostars begin to form. These processes occur simultaneously in thousands of places, but each of them remains isolated, separated by light years of emptiness. At the same time, other regions of the galaxy are undergoing the opposite process. Stars lose stability and turn into remnants, white dwarfs, neutron stars, black holes. These objects continue to exist, but in a different form. They become sources of gravitational influence, changing the movement of the surrounding matter. Against the background of these processes, Voyagers continue their movement almost unchanged. Their trajectories are not corrected. They do not depend on external forces, except for the weak gravitational influence of the galaxy as a whole. Their path becomes straight on scales where even the orbits of stars look like slow arcs. Over time, the signals from the devices become weaker. The distance increases so much that even the light emitted by them takes tens of hours to reach the nearest areas of the sun's influence. Radio signals dissolve against the background of cosmic noise created by billions of sources, pulsars, supernova remnants, active nuclei of distant galaxies. But even after the signals disappear, the movement continues. Devices pass into a state where their existence is only determined by inertia and time. At this stage, space becomes the only medium that defines them.
The Milky Way itself is not a stable structure in the absolute sense. It interacts with the surrounding galaxies. Dark matter flows hold its shape, but gravitational interactions with neighboring systems gradually change its structure. The movement towards a large spiral system, the Andromeda Galaxy, has a particularly significant impact. This system is approaching, and in billions of years, there will be a collision. But this clash will not be instantaneous. It will be a long process of intersection in which the stellar orbits will be rearranged and the structure of the two galaxies will merge into a new shape. The space between stars is so large that direct collisions of stars are unlikely, but gravitational fields will completely change the dynamics of motion.
In this distant future, the solar system will change its position within a new structure. Its orbit around the center will change, and its position in the galactic medium will change. However, Voyagers will already be far beyond all these changes, continuing to move through the expanding space of the interstellar medium. Even as the stars around them are born and die, their path will remain the same. They will pass through regions where the density of matter changes at the microscopic level, where cosmic rays create faint traces of ionization, where the magnetic fields of the galaxy form invisible structures. And all this time, the cosmos will continue to expand in its perception of scale. What once seemed like a void between stars will turn out to be a complex system of flows, interactions, and transition states. In this distant future, the solar system will change its position within a new structure. Its orbit around the center will change, and its position in the galactic medium will change. However, Voyagers will already be far beyond all these changes, continuing to move through the expanding space of the interstellar medium. Even as the stars around them are born and die, their path will remain the same. They will pass through regions where the density of matter changes at the microscopic level, where cosmic rays create faint traces of ionization, where the magnetic fields of the galaxy form invisible structures. And all this time, the cosmos will continue to expand in its perception of scale. What once seemed like a void between stars will turn out to be a complex system of flows, interactions, and transition states. The Voyagers become part of this process not as active participants, but as traces of movement left in the structure of space. Their path continues in a direction that does not lead to the goal, but crosses the infinite regions of cosmic evolution. And there is only time ahead, stretched over scales where even galaxies change shape, without ceasing their slow, continuous movement into the depths of space. Voyager's further movement takes place in an environment where the usual landmarks disappear even on the scale of stellar dynamics. Interstellar space here has no dense structures that could direct or slow down the motion. Only rare hydrogen and helium atoms, sometimes impurities of heavier elements, distributed so sparsely that huge intervals of time can pass between individual collisions.
This environment is not completely homogeneous. It consists of layers, clouds, and sparse streams formed by ancient events. In some areas, matter is slightly compacted by gravity. In others, it is blurred by shock waves from long-gone supernova explosions. These structures are not fixed. They slowly drift inside the galaxy, changing shape over millions of years. The devices cross one of these zones where the density of interstellar gas is slightly increased. The particles here collide with the surfaces of the structure,
leaving microscopic traces of erosion. These processes are almost imperceptible on timescales, but over billions of years, they gradually alter the outer layer of the metal, smoothing out the corners and disrupting the original geometry of the elements. The energy system continues to shrink. The radioisotope source, which once provided a steady flow of heat and electricity, is now operating at the limit of its capabilities. Power drops so much that systems switch between short periods of activity and long phases of complete silence. During these periods, the spacecraft becomes a completely passive object, not interacting with the environment, except for gravity and rare collisions with particles. The galactic medium is gradually beginning to have a more noticeable influence on the trajectory. Although this influence is extremely weak, on the scale of millions of years, it forms slow path deviations. These changes have no center or direction in the usual sense. They reflect the overall dynamics of the system's motion within the galactic disk.
Inside the Milky Way, the constant processing of matter continues. Stars are born from shrinking clouds of gas, then go through a full cycle of thermonuclear activity, after which they return some of the matter back into space. This process has no beginning or end in the local sense. It is a continuous redistribution of energy and matter. Over time, Voyagers enter a region where the influence of local stars becomes almost indistinguishable. Even the nearest luminaries do not create significant changes in the density or temperature of the medium. The space here acquires the character of a stable background, against which larger galactic processes unfold. But the stability of this background is only relative. On large timescales, slow density waves occur as they pass through the galaxy's disk. These waves compress matter, forming spiral structures, in which the likelihood of new stars forming increases. They then weaken, leaving sparse areas behind.
Voyagers pass through such zones without any resistance, but their trajectory gradually reflects the overall dynamics of the galactic disk. The orbits of stars inside the Milky Way are not fixed circles. They are complex trajectories superimposed on the overall rotation of the galaxy around the center. The inner regions of the galaxy rotate faster, the outer regions more slowly, creating differential motion. In this stream, the stars are constantly changing their position relative to the spiral arms, entering and exiting them over millions of years. The solar system also participates in this movement, periodically passing through denser areas of the medium, where the likelihood of cosmic factors increases. Against the background of these large-scale processes, Voyagers continue to move as independent objects, devoid of internal dynamics, but subject to an external gravitational structure. Their velocity relative to the local medium remains constant, but the direction gradually changes under the influence of the total gravitational influences of the galaxy.
Signals that can still leave the devices are becoming increasingly rare. There is not enough energy for constant transmission. Each impulse requires the accumulation of resources. These rare bursts of radio waves diverge in all directions, but no longer carry structured information in the usual sense. They become an increasingly faint manifestation of the existence of an object in space. Over time, even these impulses disappear. Systems go into a completely passive state. All that remains is physical movement through space, with no exchange of energy with the external environment, except for minimal interactions with interstellar gas particles and cosmic rays. On even larger scales, the influence of events occurring at the level of the galactic structure begins. The Milky Way interacts with neighboring dwarf galaxies, engulfing their matter and star clusters. These processes occur slowly but constantly,
Gravity redistributes masses, creating streams of stars, elongated structures, and regions of increased density. Over enormous intervals, such interactions lead to a change in the shape of the entire galaxy. The disk can thicken, the spiral arms can change their structure, and the central regions can accumulate additional mass. In the center, the density continues to increase, where the activity of the supermassive object is increased due to the influx of matter from the inner regions. In this structure, the Voyagers continue on a trajectory that becomes part of the overall flow of matter within the galaxy. Their path no longer stands out from the environment. They become elements of general dynamics, moving together with other objects, but maintaining their own inertia. Over time, the space through which they pass changes so much that the previous coordinates lose their meaning. Stars that were once nearby are shifting to great distances. New stars arise in other regions, forming completely different structures. The galaxy remains the same system, but its internal content is constantly being updated.
And even in this endless process, the Voyagers continue their movement, passing through regions where matter is in a state of near-perfect equilibrium. There are no abrupt changes, no boundaries, only a gradual flow of time, expressed in a slow change in the distribution of matter. Against the background of these processes, an even deeper dynamic begins: the movement of the galaxy as part of a local group. The Milky Way interacts with other large systems, forming a common gravitational structure. It is not a static configuration, but a dynamic system, where each galaxy influences the trajectory of the others. In this system, Voyagers become almost indistinguishable objects. Their scale is too small compared to galactic structures, but their motion still continues, obeying the same laws as the motion of stars, clouds of gas, and dark matter.
And the farther they go, the more obvious it becomes that space has no endpoint. There is no boundary beyond which the completion of space begins. There are only transitions from one state of matter to another, from one dynamic system to another, from one scale to the next. The Voyagers continue this transition without stopping or changing direction, while the time itself within the galaxy continues its slow, continuous flow, encompassing all the space through which they pass. At even longer timescales, the very structure of the galactic medium begins to exhibit changes that cannot be seen within a single generation of stellar cycles. The molecular clouds from which stars once formed gradually dissipate and then reassemble under the action of gravitational density waves. These processes repeat themselves over and over again, creating a slow rhythm of evolution throughout the galaxy.
The Voyagers continue to move through regions where the density of matter is so low that even rare atomic collisions occur at huge distances from each other. Here, outer space acquires the character of almost perfect transparency, but this transparency does not mean the absence of structure. On the contrary, at the level of magnetic fields and radiation, a thin, almost invisible network of interactions is preserved. Interstellar magnetic fields stretch for thousands of light years, repeating the general shape of the galactic disk. They are not static. Their lines bend, contract, and stretch under the influence of the Milky Way's rotation, supernova outbursts, and plasma flows. These fields become a kind of invisible architecture through which all the matter of the galaxy passes. The devices cross one of these magnetic structures. Here, the direction of the field gradually changes, creating a soft gradient that cannot be detected without long-term measurements. Cosmic radiation particles deflect slightly, following field lines, forming faint streams that pass through space without an apparent source.
In this environment, even minimal interactions become important. Cosmic rays coming from distant sources collide with rare atoms of interstellar gas, creating cascades of secondary particles. These processes occur constantly, but their density is so low that they form only background signals evenly distributed throughout space. Over time, the Voyagers enter a region where the influence of nearby stars becomes almost indistinguishable from the general galactic background. Each star in this region is just one of millions of sources whose influence is dissolved in the overall structure of the disk. The light from them spreads in all directions, but at such distances, it becomes part of the general light background of the galaxy. Then begins a region where it is no longer local stellar dynamics that dominates, but the global structure of the Milky Way. The galactic disk rotates, but this rotation is not solid. The inner regions move faster, the outer regions more slowly, creating a complex system of shifts. These shifts form spiral arms, which are not fixed objects, but density waves passing through the disk.
The galactic arms shift, change shape, disappear, and form again. Star clusters migrate across the disk, leaving behind faint gravitational trails. Interstellar gas is redistributing, creating new regions of density. In this dynamic, the Voyagers continue their movement as inertial objects, completely subordinated to the general gravitational structure. Their path is no longer associated with any local sources or events. It is determined only by the total influence of the mass of the entire galaxy. The signals that once emanated from them have long since disappeared into the background of cosmic radiation. Even if they reach distant areas, they cannot be separated from the natural noise created by billions of sources throughout space. In this noise, there is no center, no direction, only an even distribution of energy arising from an infinite number of processes.
In these waves, matter periodically contracts, creating conditions for the formation of new stars. Then it is rarefied again, returning to a more stable state. This cycle repeats itself over billions of years, forming a continuous evolution of the galaxy's structure. The Voyagers pass through these waves without interacting with them directly, but their trajectory gradually reflects the overall dynamics of the movement of matter. Their path becomes part of a larger stream, the movement of objects within the gravitational field of the galaxy. Over time, it becomes noticeable that the galaxy itself does not exist as a fixed structure. It is constantly changing under the influence of internal and external forces. Dark matter, which makes up much of its mass, forms a gravitational framework that keeps the disk from collapsing. But within this framework, there are constant changes in the distribution of matter.
On even deeper timescales, the interaction of the Milky Way with the surrounding galactic environment begins. The local group of galaxies forms a gravitationally bound ensemble where each system influences the motion of the others. Within this group, there are slow approaches, stretches, and redistribution of orbits. The Milky Way and other large galaxies move around a common center of mass, forming a complex dynamical system. This movement is not a stable rotation. It changes as mass is redistributed within and between each galaxy. The Voyagers find themselves inside this wider stream. Their trajectory, previously determined exclusively by the Sun, is now completely subject to the gravity of the entire local group. They become part of a system whose scale extends beyond individual galaxies.
Over time, a process begins that cannot be observed within human timescales: the slow interaction of the Milky Way with the Andromeda Galaxy. The two huge spiral systems gradually converge, and their gravitational fields begin to distort each other long before the actual collision. Stars in the peripheral regions begin to change orbits. Gas clouds are stretched into long structures. The inner regions of galaxies remain relatively stable, but their outer parts are already involved in complex interaction dynamics. Voyagers continue their movement within this slowly changing space. Their path passes through regions where the structure of the galaxy gradually loses its former symmetry. The spiral arms become less clear, the distribution of stars becomes more complex, and the gravitational fields become more intricate.
And yet, even in these conditions, the movement does not stop. There is no point where it should stop. There is no outer boundary beyond which the influence of the laws of physics ceases. There is only an infinite expansion of interactions in which each object becomes part of a common flow. The Voyagers continue to exist within this flow, passing through regions where matter and energy are distributed on scales that are beyond the usual perception of structure. Their path remains continuous, even as the galaxy itself changes shape, stretches, collides, and redistributes its matter in new configurations. And there is only a further deepening of this process ahead, a movement that has no final point, because the cosmos itself does not offer completion, only a transition from one state to another, infinitely continuing in time and space.